Welcome everyone in Math Simplified HM. Today we are going to see the simultaneous linear equations. A group of two or more linear equations involving two or more variables with degree 1 termed as the simultaneous linear equations. Two linear equations involving two variables with degree 1 which x plus by is equal to c, px plus qy is equal to r forms the system of linear simultaneous equations. Here a and b are not simultaneously 0, p and q are not simultaneously 0. The solution is the specific coordinate pair xy where their paths intersect. The mathematical landscape for solving simultaneous equations involves elimination method, substitution method, graphical method, determinant method. Today we are going to see the substitution method and mastering it for solving simultaneous linear equations. Consider the system 5x minus 3y is equal to 8 as equation 1, 3x plus y is equal to 2 as equation 2. In substitution method, first step is the isolation strategy. Find the value of one variable y in terms of the other, that is x. Here we see the second equation 3x plus y is equal to 2 in which y has a 1 coefficient. So by moving 3x to right, we can easily isolate y. While moving 3x from left to right, it becomes negative. We know that. Also, when we move positive term from left to right, it becomes negative, or negative term from left to right, it becomes positive. Also, you can eliminate 3x from left side by adding minus 3x to both. Thus, we get y is equal to 2 minus 3x, equation 3 here. Now, in steps 2, we substitute the value of y in other equation, that is equation 1, 5x minus 3y is equal to 8. 5x minus 3 into bracket 2 minus 3x is equal to 8. Expanding the terms, we get 5x minus 6 plus 9x is equal to 8. How? Minus 3 into 2 gives minus 6. We know that when we multiply negative term to positive term, we get the negative term. Minus 3 into minus 3x, we get plus 9x. We also know that minus term multiplied by minus term, we get the positive term. Solving this, we get 14x minus 6 is equal to 8. Solving, we get 14x minus 6 is equal to 8, 14x is equal to 4, x is equal to 1. First coordinate is found, or we get the first variable as x is equal to 1. Now consider the edge cases when variables disappear. For example, consider that when solving, we get 6x minus 4 minus 6, x is equal to minus 4, which gives us minus 4 is equal to minus 4. Also simplifying this, we get 0 is equal to 0, and this is the true statement. When we get the true statement, the system has infinite many solutions, and the lines represented by that equations are coincident lines. Another case, the false statement, that is, see here, 6x plus 4 minus 6x is equal to minus 3 gives us 4 is equal to minus 3, which is not true. It is a false statement. Also, we can get somewhere 0 is equal to 5 also. or A is equal to B, indicating that it is a false statement. In that case, the system is inconsistent or has no solution. And in this case, the lines represented by these equations are parallel lines. Now we come to the steps 3, that is the back substitution. Substitute the value of x obtained in step 2, that is in equation y is equal to 2 minus 3x, which gives y is equal to 2 minus 3 into 1. Solving, we get y is equal to 2 minus 3. Finally, y is equal to minus 1. We get the final solution as x is equal to 1, y is equal to minus 1. We can write it as in bracket x comma y is equal to in bracket 1 comma minus 1. Let us verify it. Check. We have 3x plus y is equal to 2. We substitute x is equal to 1 and y is equal to minus 1. We get 3 minus 1 is equal to 2. Finally, 2 is equal to 2. Thus, the solution verifies the equation. The final recap. First step is isolate, that is find one variable in terms of other, y is equal to 2 minus 3x here. Now substitute this value of y in another equation, that is 5x minus 3y is equal to 8. We get x is equal to 1. Now put this x is equal to 1 in equation y is equal to 2 minus 3x. We get y is equal to minus 1. Thus, in substitution method, first step is isolate, second step is substitute, third step is solve. Thank you. We have seen how to solve the simultaneous equations by substitution method.